Welcome to the lair of the Batty Boffin.
Hi there, Batty fans. Time for a little more maths, and this time we're talking about surds. What exactly are surds? Well, surds is just an easy way of writing things down. Now, I have to say, if you've just started doing surds and you don't know really what they are, they probably don't look like an easier way of doing it at all. But let me just show you. Here we've got a number, you're probably familiar with this, 3.141592777. We don't usually bother writing that down. Instead, we just write pi. Two reasons for that. Firstly, it's shorter, and secondly, it's more accurate. That, of course, however far you write it down, is always only going to be an approximation. Here's another one. 3.125. Mean anything to you? No, probably not. It doesn't mean most to most people. That's actually the fraction 5/16. Now, as 5/16, we know exactly what that is. Now, that actually is accurate. It's a terminating decimal, but it means so much more when we write it as 5/16. We know that's a bit more than a quarter, isn't it? And it's the same as, 10, 30 seconds and things like that. So writing it as a fraction has a lot more meaning to it. And this one down here, 2.23606 blah 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 blah. Any ideas? No, me neither. But I happen to know, because I worked it out before I put the video on, that is the square root of 5. And again, we'd write the square root of 5 rather than this decimal for two reasons. Number one, it's shorter, and number two, it has meaning. We know what we mean by the square root of 5. And if we write down this, however many decimal places we use, it's always going to be an approximation. And of course, if you approximate this and then square it, let's say we wrote that to 2.236. 2.236, and then we square it. 2.236 squared gives you 4.99969. Which is very nearly 5, but it isn't. Whereas if you take the square root of 5 and square it, you get 5. So this is a surd. It's a number written in square root form, and the reason we do it is because it's more accurate. Now, talk amongst yourselves while I just wipe some things off the board and give you some examples. Right, ready to go? Now, I've got some square roots here that, actually, to be honest, you should be able to do these, but I'm doing these with nice easy numbers so you can see the principle, and then we'll do it with yucky numbers later on. First of all, we've got the square root of 100. Well, hopefully you know that's 10, so we should end up with 10 as our answer. But I'm just going to show you one of the principles that we can do with manipulating surds. I'm actually going to rewrite that 100, and I'm going to rewrite it as 4 times 25. So square root of 100 is the square root of 4 times 25. And then here's the magic bit. The square root of 4 times 25 is the same thing as the square root of 4 times the square root of 25. If you think about it, it works the same as with powers. If I do a times b and then square the whole thing, that's the same as a squared times by the b squared, because they're all times together. It works kind of the same with roots as well. Okay, this is now dead easy. The square root of 4 is 2. The square root of 25 is 5. And 2 times 5, of course, is 10. So it does work. Okay, we've shown it here with easy numbers. We split up the number under the bracket, under the square root, into something convenient. Square root the 2 bits. So what we're doing is splitting this square root into the 2 chunks. It works exactly the same with divides as well. So I know we could do the 36 divided by 4 and get it, but again I want to just show you the principles. So what I'm going to do here is split up that divide and the square root. We've got the square root of 36 divided by 4, and I'm going to split that into the square root of 36 over the square root of 4. Square root of 36 is 6. Square root of 4 is 2. 6 over 2 is 3. And that is correct, because 36 divided by 4 is 9, and the square root of 9 is 3. So that's it done with numbers. Here it is done with the letters, just so you've got some general principles. Okay, here it is in general terms. The square root of AB is equal to the square root of A times by the square root of B. And similarly with the divide, the square root of A over B is equal to the square root of A over the square root of B. Now, go and get a cup of coffee, make some pizza or something, come back in about 3 seconds when I've got a new board of things for you to have a go at. Right, now that we've seen what we can do with surds, splitting them up over the multipliers and the divides, here's a question for you to have a go at. What is the square root of 20? Give your answer in surd form. Okay, so square root of 20, there it is, and we're going to split up that 20. I'm going to write it as the square root of 4 times 5. Now, I could have written that as the square root of 2 times 10, which would also be true, but you'll see in a minute why I've picked 4 times 5. So now we're going to split that square root. The square root of 4 times by the square root of 5. Right, now you can see why I picked the 4 times the 5. Square root of 4 is dead easy. Oops, don't need a square root there. It equals 2. And then root 5 is just root 5. That doesn't simplify because it's not a square number. So 2 root 5. Square root of 20 is equal to 2 root 5. Now that's the end of this video, but come back to the next one where you'll have a whole load of examples to have a go at yourself. See you next time, Batty fans.